Hello, and thank you for joining me today as we start our discussion on forces and specifically Newton's first law. So Newton's first law of motion is something that we see every day in our lives. So for example, if you started sliding a book across a rough surface, for example, carpet, so try sliding a book across carpet, your book is going to come to a stop rather quickly. However, if you were to take a book out to a frozen pond and slide it across the ice, there's a good chance it'll slide a whole lot farther. And the reason that is because friction between the ice and the book is much less than the carpet in the book. And without friction, it would actually keep on sliding forever. And this is where Newton's first law comes in. So his first law states that an object in motion stays in motion, an object at rest stays at rest, unless they are acted on by an unbalanced or outside force. So unless there's an outside force acting on something, it's going to maintain its state of motion. So we're going to look at that here today. Let's clear all those. So objects tend to maintain their state of motion. That's what his law says. For example, when you're bowling, your ball moves down the lane until it hits the pins. If the lane went on indefinitely and had zero friction, bowling lanes are close, not perfect, but close, and had zero friction, your ball would just keep rolling. And these pins would stay put until the ball hits them. So for example, you roll a gutter ball, those pins don't move because there's no outside force to make them move. In the real world, if friction would eventually cause this ball to stop, just like everything else. So eventually friction is going to take over and that object is going to quit moving. But in theory, if there were no friction, things would move indefinitely. Okay, so another term that is used with this is we have this word called inertia. And so inertia is a property of matter that describes the tendency of an object to resist a change in motion. For example, an object at rest is going to stay at rest, object in motion is going to stay in motion. So an object without an outside force, there is no change in motion. Okay, so an object with a small mass, for example, a baseball, can be accelerated by a small force. If you apply that small force to a larger mass, it's not going to move as much. So objects with larger masses, for example, a car, requires much greater force to make it move. And there is no equation for inertia. There's no cut and dry formula. There's no units, but mass is our comparison value for inertia. Objects with small mass will have less inertia than objects who have a larger mass. And so because inertia deals with objects changing their motion, Newton's first law is also called the law of inertia. So that is Newton's first law as well. It's another word for it. Because of inertia, when you're riding in a car and you make a sharp corner, so if you're driving a car this way and you make a sharp corner here, or you're in a bus and you make a sharp corner, you will slide to that side of the bus and people on the end will hit the windows. And the reason that is because you are moving in this direction here, you're moving this way, and so your body wants to keep moving this way, and so it hits the outside of the bus, and that's what allows you to turn. So you continue in the same direction you're moving while the car turns. The same reason cars have seatbelts. So this is the reason planes, cars, and bikes can't stop you instantaneously. So this is why it takes time. And when you are in a car and you slam on the brakes, this is why your seatbelt will dig into your shoulder and waist. So this is all to combat inertia. So this is just looking at those situations and the safety precautions of cars. That is today's discussion on inertia. I look forward to talking through the rest of Newton's laws with you and enjoy the rest of your time.